Okay, it's time for some more practice involving our squeeze theorem and, of course, our favorite limit, sine of theta over theta as theta goes to 0. As always, whenever you're working on these problems, try to do as much as you can on your own first. So make frequent use of that pause button and only see the solutions either once you figure it out or if you're really stuck. And you should always try like, ah! Don't just be like, kind of stuck. No. You got to be really stuck before you see what to do. The more you do on your own, the better that you're going to be. And we want you to be the best. All right, so let's get right into it. Find the limit as t goes to 0 of 1 over square root of 9 plus 2t minus a third over sine of 3t. Interesting looking problem. Okay, well, the first thing you should always check when you're doing any problem is just say, what happens when we plug 0 in? Because, that's our limit as we're going to 0, right? So upstairs, you get 1 over square root of 9, which is a third, minus a third. So upstairs, we're going to 0. Downstairs, sine of 0 is 0. So it's 0 over 0, which means more work. More work. That's okay. We don't mind more work because we'll get to do some elegant math along the way. Okay, good. It reminds me of one of the things my teacher said when I was a college student, that what's a vacation for a mathematician? A vacation is a period of uninterrupted work. Okay, so we get to go take a small vacation now. Well, one of the things that we see right away is we see there's a mixture of sort of algebra things and trig things. So we know in the back of our head, we're going to have that there's this limit as, I'm going to write blah goes to 0. No, don't write blah, but whatever. I say blah just to sort of like, hey, let me not get caught up on particulars. I just need to make sure the insides match. So in other words, what's inside the sign matches what's in the denominator. And if they do, and it's going to 0, life is good. And we want life to be good. All right, so our goal, because we have that sign and some algebra floating around, we're going to try to get to something like that looks like this somewhere, and hopefully that takes care of our 0 over 0 situation. So we begin. Well, what can we do? Well, there's a couple of things we can do. Let's start by putting these terms together. So we'll start by saying, take our limit, t goes to 0, and common denominator would be if you multiply these two things together. So you would get 3 over 3 square root of 9 plus 2t minus square root of 9 plus 2t over 3 square root of 9 plus 2t. So get a common denominator. Then I have that sine of 3t downstairs. For right now, I'll just write it as 1 over sine of 3t. Just because, fractions within fractions looks a little bit messy sometimes. All right, we'll put those things together. So we get that this is our limit as t goes to 0 of 3 minus the square root of 9 plus 2t. And then, of course, downstairs, what do we have? We have ourselves a 3 square root of 9 plus 2t. That's our denominator. And our sine of 3t. Okay, so far, so good. Now, we need to do something with this 3 minus square root of 9 plus 2t. There's a square root. And when you see a square root, and it's also something involving a 0, because we have a 0 upstairs. Look, we want to get rid of our square root so we can somehow tackle getting rid of that 0. And that's when we pull out our conjugate tool. So we're going to multiply both the top and the bottom. By conjugate, we mean flip the sign. So 3 plus square root of 9 plus 2t. Downstairs, 3 plus square root of 9 plus 2t, because you got to multiply the same thing on the top and the bottom. We got to make sure we don't change our problem. So what do we have? So we have our limit as t goes to 0 of 3 times 3. That's our a squared, if you will. So 9. Then you get your, what we call the cross terms. 3 square root of 9 plus 2t minus 3 square root of 9 plus 2t canceled. Then the last term, we get rid of the square root, so minus 9 plus 2t. Downstairs, don't expand. You don't expand because it's not going to help you. If anything, it'll just frustrate you. We don't want to be frustrated. We want to be calm and relaxed. After all, we're doing math. We should be enjoying it, right? All right, now we're in a pretty good state. Let's talk about things we can do. Well, easiest thing to spot is we can cancel some 9s. Okay, like I said, easy thing to spot. Now let's talk about our 3t here. We have sine of 3t. So in preparation to deal with that, let's put an over 3t right there. Okay, so that makes it so, I can get rid of that. When I say get rid of that, I mean I can control that limit. I understand that part. If I put a 3t there, what else do I need to do? I have to compensate. So where do I need to put a 3t? Well, I'll put a 3t there. You see how those 3t's would cancel out, and so we get 1. Now, let's be careful here, because we don't want to come this far and make a mistake. So, one thing to be careful about, see this minus? It comes through. Remember, parentheses are your friends. Use them. Hang out with them. Get to know them. There's left parenthesis, there's right parenthesis. And make sure you distribute your minuses through. So, minus 2t. Now, downstairs, well, the 3 and the 3, that can combine together, and I'll put that as a 9. I'll go ahead and put the t there. And then we have square root 9 plus 2t. And I'll move this 3 plus square root of 9 plus 2t there. And then, of course, sine of 3t over 3t. Good. We're all there. The gang's all here. Now, we see the t's cancel. And this is our great woohoo! We're getting cancellation of zeros. We want the zeros to go away. So in essence, we've knocked out the 0 over 0. Or at least we've knocked out 1 0 over 0. Usually that's all we have at this point. We'll get into cases later on where we get multiple rounds of 0 over 0. It's going to be good. It's going to be good. So now let's work through our pieces. So the t's are gone. The negative 2 does what? Well, it's negative 2. It doesn't change. The 9 is 9. How about the square root of 9 plus 2t? What would that do? Well, you're going to get the square root of 9 because 2t is going to 0. So square root of 9 says that's going to 3. How about here? You get 3 plus the square root of 9 because, remember, t is going to 0. So that's 3 plus 3. So that part is going to 6. And how about the sine of 3t over 3t? That's our sine blah over blah. We pull that out, and we didn't write it down, but that's equal to 1, which means that this part goes to 1. So we say, look, we have control over each piece. Nothing goes to anything uncomfortable. An uncomfortable thing is a 0 in a denominator. We don't have that. And so we get our answer, right? It's negative 2 over 9 times 3 times 6 times 1. Now, 2 and 6 both have a common factor of 2, so I'll go ahead and cancel that. And 9 times 3 is 27. 3 more makes 81, so we end up with negative 1 81ths. And there you go. We got it. Good, good. Patience, right? Rewrite it, make it something easier to work with. Well, of course, we always want to make things easier to work with. You don't go and say, hey, let me make this harder to work with. That's not the math way. That's not the math way at all. All right, good. Well, let's try another one. Find the limit as t goes to 0 from above of 4t plus 5t squared of sine squared of log of t squared, divided by t minus the square root of t plus 4 plus 2. All right, now let's talk about what's happening here. Downstairs, when you plug in 0, you get 0 minus square root of 4, so that's minus 2 plus 2. So you get 0 downstairs. Here, 4 times 0 is 0. And here, you get 5 times 0, but that's going to be really peculiar. Now, why do I say that? Well, think about log. If you know the log function, and of course, who doesn't know the log function? What a silly question. But if you think about the log function, what's happening is it does this. So as you get close to 0, and the t squared is getting close to 0, it's heading off towards minus infinity. So what's happening is that the inside the log function is really shooting off to a very large value, in this case a large negative value, which means that this piece right here, so when I say this piece, let me box it, this piece right here, it's doing that crazy oscillation thing, right? Where it's just wildly oscillating near 0. So it's just like, gotta be careful with that one. So we want to be careful. So we're going to sort of work our way around here and massage things. Our hope is whenever you have something going crazy up and down, we say to ourselves, hey, it is going crazy up and down, but it's going crazy up and down in a nice way, because this is going to be a bounded function. And when you have something being bounded, there's a glimmer of hope. All right, so let's get to work on thinking about what we can do to figure this out. Now, looking at this, we can see that we have our denominator. Let's try to get rid of the square root so we have something more convenient to work with. We know we have a 0 happening downstairs, so we do want to get rid of the 0 somehow. We want to get a cancellation, which means we should try to get rid of the square root. So how do you get rid of square roots? Well, you do what you almost always do, which is you use the conjugate. So we have our limit as t goes to 0 from above of the top is what it is, 5t squared sine squared log of t squared. Boy, I really like squares there. Now, let's be careful with our conjugate. Remember, conjugates are when you take something that looks like a minus b and you multiply it by a plus b, which means I need 2 pieces. What are my a and my b? So to answer that, well, we have to say, we know we want the square root to be one of our 2 parts because we're trying to get rid of the square root. So, okay, so we'll say, okay, so that's one of our pieces. So what we should think of is everything else is the other piece. So we'll have this as t plus 2. I'm going to put parentheses just to emphasize we're thinking of it as like a group. T plus 2 minus the square root of t plus 4. And that's just what it is. Now we're going to multiply by the conjugate. T plus 2 plus the square root t plus 4. And if we do that to the downstairs, then we also have to multiply the upstairs. T plus 2 plus square root t plus 4. All right, progress. Well, maybe. What happens when we multiply everything downstairs? So we get this is the limit as t goes to 0 from above. Upstairs, not much you can do. Let us go ahead. Notice that these both have t's attached. So this is t. I'll pull out a t. 4 plus 5t sine squared log of t squared. Then we have our t plus 2 plus square root of t plus 4. Okay. Downstairs, t plus 2 squared. Now, we can actually square that out. That's t squared plus 4t plus 4. So that's the t plus 2 times t plus 2 minus the t plus 4. So t plus 4. So, very conveniently, almost as if it had been planned. It may have been planned. What do we notice? That 4 and that 4 will cancel. So, this denominator becomes t squared. 4t minus t is 3t. Or if you like, it's t times t plus 3. So that's what we have downstairs. What do you see there? there's a t. There's a t. So we have two t's, one upstairs, one downstairs. We can cancel them out. So we have, this is our limit as t goes to 0 from above of 4 plus 5t sine squared log of t squared. Let's see, do I have enough parentheses here? I feel like I'm always missing parentheses. Sine squared, oh, I missed a parentheses there. There we go. T plus 2 plus square root of t plus 4. And downstairs, t plus 3. Now, let's think about our pieces. What's happening to every piece? And if each piece is good, then we're done. Life is good. We've won. So, t plus 3. T is going to 0. T plus 3 goes to 3. That's a good thing. 4. 4 is a nice number. It goes to 4. How about this expression? T plus 2 plus square root of t plus 4. Well, you're going to get 0 plus 2 plus square root of 4. Well, that's 4. That's a nice expression. Which leaves us with this thing. And the question is, what do we do with that? Okay, so now let's come off to the side and think about that. We have our expression 5t sine squared log of t squared. Now, this part right here, sine squared log of t squared, we actually know something about this. This is bounded. In fact, we can say that sine squared of log of t squared, the smallest it can get is 0, because you're squaring it. It can't be negative. So this is at least 0. What's the largest? Well, because sine goes between negative 1 and 1, sine squared goes between 0 and positive 1. So I multiply by 5t. And here I'm going to use a little fact that I normally would obfuscate, but because we're friends, I'm going to share with you a little thing that says why I'm not cheating. I want to multiply by 5t. Normally I have to be cautious and say, well, what if t were negative? But I don't have to do that. Why not? Because look where t is. There's this little tiny thing right up here. We haven't really talked about yet. But now I marked it. What is it? It's a plus, which means that we're approaching 0 from above. T is positive. So 5t is a positive value. So if I multiply, I don't need to worry about the inequalities. They follow the same pattern. So that says 0 is less than or equal to 5t sine squared log of t squared is less than or equal to 5t. Now we ask ourselves the question, what can we say about what happens as we head towards 0? Well, certainly 0 goes to 0. That's easy to spot. How about 5 times t as t goes to 0? Well, that's easy too. That's 0. Now, this crazy function has to be in between. So what is it going to do? By squeezing, that is also going to have to go to 0. So this really unpleasant looking piece goes to 0. Woohoo! Nice. We like it when we have a 0, especially, added 0 or 0 in the numerator. That's good stuff for us. So we're ready to put it all together. So we have 4 plus 0 times 4. Well, 4 times 4 is 16. And downstairs, 3. So 16 thirds. Exactly what we would have thought when we started, right? Maybe not. We had to do the work. But that's all right. We don't mind. A little bit of work. It's not a bad thing. Okay, good. Well, let's try another one. Okay. Let f of x be the function shown in the picture below. Here it is. Determine the limit as x goes to 1 of f of f of f of x, or show that the limit does not exist. So this is an f of f of f of x. Well, there's lots of layers here. Many layers of f to go through. And the thing is, we don't actually have the function explicitly. We only have a picture. So we have to be able to say, let me read the picture and see what's going on. Now, one thing that's pretty clear to see is that this function is defined by pieces. So we're going to think of our piecewise mentality. Now, piecewise mentality says when you're dealing with limits, do one-sided limits. So we're going to do one-sided limits. So let's pick a side and see where it gets us. So let's start by saying we'll do the limit as we approach 1, say, from below of f of f of f of x. So what we're going to do is we're going to work through this sort of by layers. It's an onion type problem, that there are layers. And also, maybe a couple tiers will be involved by the time we hit the end. So the way we start is to say, let's go through from the inside. What do we know about x? Well, that's easy. X is approaching 1 from below. So this layer says you approach 1 from below. No surprise. Now let's go to our next layer. So in our next layer, I'm looking at what happens to our function f as the inside approaches 1 from below. So I come from here. Now, approaching 1 from below means I'm approaching from the left-hand side. As I approach 1 from below, what is f doing? Well, it's going towards 4. Well, let's be careful. How is it going towards 4? You see, as I go towards 4, I'm going from a lower value to a higher value, which means that in my next layer here, this next layer is approaching 4 from below. Okay, because I'm going to 4 from a lower to higher point. Okay, now we're ready for our next layer. See, our next layer says I want to understand f as the input, which is this whole expression f of x, is approaching 4 from below. So I'm approaching 4 from below. So 4 from below means 4 from the left. So I'm coming here. Now, as I approach 4 from below, I'm approaching this value of 2. In what way? I'm coming from a higher number to a lower number, which means that the next layer is approaching 2 from above. Okay, so now we're ready for the next level. So I have f of something. The something is approaching 2 from above. So as I'm approaching 2 from above, so I'm coming from 2 from the right-hand side, what do I approach? I approach 3. And in fact, I can even say explicitly, I'm approaching 3 from above, right? Because I'm coming from a high to a low. So 3 from above. So, well, that's our last layer, which means we get 3. So the limit as we approach 1 from below of f of f of f of x is 3. Good. Aha. Well, that's one direction, but we need another direction. So the other direction probably won't surprise you. 1 from above. F of f of f of x. 2, 2, 2. Okay, let's do this. So, inner layer. We know what's happening. We're approaching 1 from above. Okay, because that's what the limit says to do. Now, we want to go to our next layer. Our next layer says our input is approaching 1 from above. What is the function f doing? So, as we approach 1 from above, we are approaching 2. In what way? We are approaching 2 from below. So, right, see how it's coming from below? Because we're going up towards 2. So from a smaller value to a larger value. So approaching 2 from below. Now, for our next layer, we now want to look at f as what's coming into the function goes to 2 from below. So what happens to f as we approach 2 from below? So here's 2. We want to come from below, so we're coming from this side. Our function is approaching 4 in what way? It's approaching 4 from above. So, and why do we say above? Because we're higher than lower. 4 from above. All right. One layer to go. So, last layer. So now I want to understand my function f while the inside part is approaching 4 from above. So I come over here and I say, well, if I'm approaching 4 from above, so I'm coming from the right-hand side, I'm approaching what? The answer is I'm approaching 3. So this is a limit as I approach 3 from above. It actually matches here. Not only does it approach 3, it even approaches 3 in the same way. They both come from above. But the important thing is not that they approach 3 from above, it's that they both approach 3. They agree. They both line up. So whatever this function looks like, and it's a weird looking function, and I don't think I could probably do it without a computer, I can come to the conclusion that since these limits agree, then the limit as x approaches 1 of f of f of f of x is equal to 3. That's a good one. That's a good one. It almost feels like we're testing our artistic ability, but we're also sort of testing our ability to understand and to read diagrams. The ability to understand functions by both an algebraic expression or trigonometric expression is useful, but also to see it from table, to read data from table, and to read data and information from a graph. We're going to see all three of these throughout our calculus courses. So you want to be able to be flexible and interpret in multiple different ways what functions can be given to you as. That brings us to our last problem. Oh, well, for now. There's always more problems, right? So time to really stretch and flex our calculus muscles here. So limit as x approaches 4. Whoa, 4. It's not 0. It's nice to have something different. Sine of x minus 4 over the square root of x plus 12 minus, oh my goodness, is that 2 square? It's 2 square roots! They put in 2 square, why would they do that to us? Okay, anyways, gotta calm down. Square root of 3x plus the square root of 2x plus 8. Okay, wow. Well, let's plug in 4 and let's see what we have. Maybe this is going to be like 10 seconds because we'll get something nice, right? Let's see. 4 minus 4 is 0. Sine of 0 is 0. Okay. Square root of 4 plus 12. That's square root of 16, so that's 4. And let's see. Well, here's another square root of 16 because 2 times 4 is 8. So that's 4. Then we have 3 times 4 is 12. So 12 plus 4 is 16. So that's minus another 4, which is 0 over 0, which means, oh my goodness, who would have thought? More work. More work. Okay. All right. Well, let's do the work and see. I'm looking forward to this. This is good stuff. This is good stuff. So we know in the back of our mind that there's a couple things. We see a problem like this, and there's 2 things that should jump into mind right away. The first thing is we see that there's a trig function, in particular a sine, then algebraic stuff. So the first thing that should pop into our mind is the following. Namely, the limit as blah goes to 0, sine of blah over blah is indeed going to equal 1. That's the first thing. At some point, I bet you we're going to use that. The other thing that should pop into our mind is because we have square roots, we should be thinking conjugates. Okay, and probably we're going to have to go through a couple layers here because we have a square root inside of a square root. It's a double square root, but that's all right. We like a good challenge, and we should always challenge ourselves. We shouldn't back away from a challenge. We should meet a challenge head on and say, look, I know you're a challenge, but solving you is going to make me better. And my goal is to be good and great. Okay, so let's work our way carefully. So right now, there's not much I can do with this sine blah over blah. So I'm going to hold off on that for a little bit and come back to it later on. So I'm going to focus on the square roots first. So limit as x approaches 4, I have the sine of x minus 4 upstairs, and then I have the square root of x plus 12 minus the square root of 3x plus the square root of 2x plus 8. Okay, so let's get rid of the first layers of square roots. In fact, this is a great time to use the conjugate because now, normally the conjugate you only have one piece that has a square root. Both the pieces have square roots, so it's like we're getting a double bonus by using the conjugate. Conjugate, you're so good. Okay, so square root of x plus 12 plus square root of 3x plus square root of 2x plus 8. Upstairs, square root of x plus 12 plus square root of 3x plus square root of 2x plus 8. All right, now we multiply this out. So this is limit as x goes to 4. Upstairs, well, when I say multiply it out, you multiply the denominator. Don't multiply out the numerator because you only multiply out where it's going to help you. Don't multiply out where it's not going to help you. So 3x plus square root of 2x plus 8. Okay, downstairs. This is our a minus b, a plus b. So a squared is x plus 12, and then minus b squared. So minus, parenthesis, 3x plus the square root of 2x plus 8. All right, now let's work on the denominator for just a second here. So we're going to switch colors so we can keep track of what we're doing. So what do we have? We still have a square root, so we need to get rid of the square root. So what we want to do is rewrite it in a convenient way for us. So notice we have an x, and then there's a minus 3x, so that would become a minus 2x, because I can combine the x and the minus 3x. Then there's a plus 12. And now minus, because that minus comes through, square root of 2x plus 8. Okay, so we've rewritten it as the square root is one piece, everything else is another piece. Now you could pause and say, well, hey, maybe now we're not getting 0, but we will get 0 again. Plug in 0. You get negative 8 plus 12, which is 4, minus square root of 16, which is 4. The reason we know we should get 0 again is because we haven't done any cancellation. And if you got 0 before, it's not going to go away. There's still something causing the 0. There's a fundamental 0 here, and we want to make sure we get rid of that. Okay, well, what to do? Well, so now we're going to multiply again by the conjugate. So negative 2x plus 12 plus square root of 2x plus 8. And we're going to do it both upstairs and downstairs. Okay. Now, what do we have? Well, at this point, we have the upstairs is getting really packed. Well, that's all right. That happens. So sine of x minus 4, square root x plus 12 plus square root 3x plus square root 2x plus 8. And then we have a new piece, minus 2x plus 12 plus the square root of 2x plus 8. And downstairs, okay, so a squared minus 2x plus 12 squared minus b squared, so minus 2x plus 8. All right, we need to work on our denominator. So let's get to work on it. What can we do? Well, first off, let's square this out. So minus 2x squared, 4x squared. So think of it as a squared, then there will be 2ab. So minus 48x. Yeah, that's there. Plus 12 squared, 144. Then minus 2x minus 8. All right. Now, let's clean that up. Well, first thing, everything has an even number in front of it. So let's go ahead and factor out a 2. So it'll be 2 times, there's only a single x squared. So when I factor the 2 out, that'll leave me with 2x squared. Minus 48x minus 2x is minus 50x. But I'm factoring out a 2, so that's minus 25x. 144 subtract 8 is 136, right? It is, it's 136. I hope. Well, I'm going to pretend like it is. All right. If you take 136 and factor out a 2, what are you left with? 68. All right. So plus 68. Now, actually, let's do a quick check. How can we see if what we did is right? We know we haven't canceled our 0 yet, and we know there was a 0 downstairs. So if you plug in 4, we should get 0 again. So let's just quickly do that computation. 2 times 4 squared. Well, 4 squared is 16. Double that is 32. 32 plus 68 is 100. 25 times 4 is 100, but then there's a minus. So we get cancellation. Good. That's a sign we've done it right. Whew. Wait a second. That also tells us what we do next. You see, what do we have? This factors. So there's a 2 in the front. Because when we plugged in 4, we got 0, that means 4 is a root, which tells us that there's a factor of x minus 4 available for us. So that's one of our 2 factors. Well, how does the rest go? Well, the thing is, we don't even have to think too hard, because I have an x here. X times what gives me 2x squared? The answer is x times 2x gives me 2x squared. Now, how about the 68? So minus 4 times what gives me 68? Well, it's negative 17. Now, you can check. Negative 4 times negative 17 is 68. And you can also, run it backwards now. 2x squared, good, minus 17x minus 8x, minus 25x, and then plus 68. So that tells us our denominator has an x minus 4 as a factor. We anticipated it would, because since we had a 0, we anticipated that if we worked enough, and we've done some work, we'd get an x minus 4 there. Notice now we're ready to say, hey, wait a second, I have a sign of x minus 4. My blahs are matching up. So we're almost there. We're definitely in our home stretch. So the hard part is just going to be writing this and having it fit. So x goes to 4. I'm going to put this x minus 4 from the denominator underneath the sign of x minus 4. So sine of x minus 4 over x minus 4. Now, what do I do with everything else? The answer is I just write it all out. In essence, here is my 0 over 0. And I know how to handle that kind of 0 over 0. Okay, so what is everything else? Well, there's all this stuff upstairs. So square root x plus 12 plus square root of 3x plus square root of 2x plus 8. Then times that by minus 2x plus 12 plus the square root of 2x plus 8. Downstairs, we have the 2, because we haven't done that. We already grabbed the x minus 4, and we have the 2x minus 17. Now we go through this and ask ourselves the question, what happens? Here we have x minus 4. They match. That's good. Now you might say, hey, wait a second. Is this going to 0? Well, remember, x is going to 4. If x goes to 4, x minus 4 does go to 0. So we're in the right form. Blah. It's going to 0. Yes. So this piece is going to be nicely behaved and goes to 1. The 2 goes to 2. Now, plug in 4. 2 times 4 is 8. 8 subtract 17. Well, 8 subtract 17 is negative 9. All right, good. Making progress. Okay, upstairs. Square root of 4 plus 12. That would be 4. Then there's a plus. Here, we'll get square root of 12 plus square root of 16. Well, that's going to be inside of that square root of 16, so it's really a 4 plus a 4. It's actually not a surprise that these are the same, because remember, we did it to get rid of, there was a 0 being caused, so it was like 4 minus 4 if you come back up here. So the fact that there's a 4 plus 4 is actually like, that's what should be happening. It should be same plus same. If there was not same plus same, it would make us think like, we've made a mistake somewhere. And it wasn't to sign up for calculus. That was not our mistake. All right. Well, okay. Anyways, we keep going. Plug in 4. Minus 2 times 4 minus 8 plus 12 is 4. And again, plus square root of 8 plus 8, 16. 4 plus 4 again. All right. Good. And now you notice everything's great. So we put it all together. We've kept our limits, but now we say, look, we can take our limits of our pieces. There's no problems. And since each piece works, our answer is 1 times 8 over 2 times negative 9. Now I can cancel a 2 by dividing it in. So we end up with negative 32 ninths. Exactly what we would. No, come on. We would not have guessed negative 32 ninths. But we were patient, and our patience paid off. All right. That's a good one. That's a good one. Well, hopefully we get some more good ones in the future too.